Hello everyone, welcome to lesson 6.3a, Law of Conservation of Energy. So our major concept here is really that energy cannot be created or destroyed. Destroyed, sorry. Spelling error, oops. Which means the energy before has to equal the energy after. Energy before equals energy after. Now, in this case, a general formula, because in Physics 20 we're basically dealing with mechanical forms of energy, specifically kinetic and potential, we can say that the kinetic energy plus the potential energy, these are the energy before, is equal to the kinetic energy after plus the potential energy after. These little ticks really just mean the after. Now this is not on your formula sheet, this is just a general formula to kind of isolate the concept. And the other thing is, if we pick points that some of these things do not apply to, you can actually eliminate them right out of the system. So, now I know some of these questions we've done in a way that has been done with kinematics, but we're going to use the law of conservation of energy in these cases. So, heavy object dropped from a height of 12 meters. What speed does it hit the ground? So, kinetic energy plus the potential energy before equals the kinetic energy after plus the potential energy after. However, at the beginning, there is no kinetic energy. It's dropped. It has no energy. And at the end, there is no potential energy. So, you're left with mgh is equal to 1/2 mv squared, and notice the masses cancel out, and this will happen with each of these cases. So 2gh square rooted is going to get you v, and when you plug in 2 times 12 times 9.81 all square rooted, you wind up with 15.3 meters per second. Now you may also notice that this is very similar to the kinematics formula. Vf squared is equal to Vi squared plus 2AD, where the Vi was canceled out. And as you can see, essentially, that's exactly the same thing that we did. Right? We just used the concept of the law of conservation of energy. So, similar sort of situation. If we've got a heavy object, but this time we're throwing it down. Okay. So we do have potential energy. We have kinetic energy at the beginning, but at the end, we have no potential energy as this object falls down. So we've got mgh plus 1/2 mv squared is equal to 1/2 mvf squared. Again, masses cancel out of every term, not just two of them. And multiplying everything by 2, you got 2gh plus vi squared is equal to vf squared. This is again the same formula that you would be using potentially with the kinematics. We're just using the law of conservation of energy. 2 times 9.81 times a height of 500 plus 10 squared is equal to vf squared. You're going to get, calculating all of this, is equal to vf squared, or 99.5 meters per second is equal to VF. The thing is, though, is that this concept doesn't just apply to falling objects. Here, if we've got a roller coaster at rest at point 1, and at maximum speed will be when this potential energy converts to the most potential. And so this is where we got the max speed. So it doesn't really matter how high this roller coaster is above this point. It's just relative to this point because energy is there. And so, again, EP plus EK is equal to EP plus EK. But because of where we're defining our reference point as being point 2, we start off with no kinetic energy and end off with no potential energy. Okay, mgh is equal to 1/2 mv squared, or 2gh all square rooted is equal to v squared, v. So 2 times 9.81 times 35 meters gets you v, or v is now equal to 26.2 meters per second. Now, if we were to take a look at this at point 3, again, because of the difference, we can establish point 3 as our reference point, which means that this would only be a 7-meter drop. So our procedure winds up being the same, except it's only a 7-meter drop to get V, which winds up being 11.7 meters per second is equal to V. And so this is a method that we can solve many of the problems based on the concept of conservation of energy. Okay, as you're doing your homework, I know you might be tempted to do things via kinematics. However, please do everything according to the law of conservation of energy, as we are going to be building upon this. So, thanks for watching and hope it helps. If you got any questions about homework, please give me a shout. Thanks. Bye.